This is a video for lesson 15 talking about transformations. So on Thursday we talked about how this is a general form of the equation f of x is equal to 1 over x, and including all of the transformations, we have a plus b over x minus c, where each of the variables a, b, and c represents a different transformation. So a represents shifting up and down, b represents a flip or a vertical stretch. So flip is when the value of b is negative, and then we have the variable c that determines whether the graph shifts to the left or to the right. So the general form of this graph looks like it has a shape like this. Okay. So once we have the general form and we know what the values of a, b, and c are, we can go ahead and just shift this graph up and down as necessary, left and right, and also flip it or stretch it as these variables tell us to do. Now, Friday's examples, our rational expressions look more like this. We often see them in this form and not this form. So our goal is to rewrite this into this form. So how do we do that? So there are actually two methods that I'm going to go ahead and show you in changing this rational function into this form so that we can tell what the transformations are. So let's go ahead and do that. So the two methods that I've named are method 1, which is long division, which you guys know how to do, and I will show you guys how it applies in this case. And method 2 is pattern matching, and I'll talk more about that. Okay, so let's go ahead and work with this example. So our function for example number 1 is f of x is equal to x plus 2 over x minus 3. Now, how do we do long division? As a reminder, we are taking our top x plus 2, dividing that by x minus 3. Okay. So first we need to think about what number do I need to multiply by x to get to x, and that would be 1. So 1 multiplied by x and I get x. 1 times negative 3 is minus 3. Don't forget you're subtracting all of this, just like in regular division. So once I do that, I have x minus x, that's 0, to minus negative 3, that is 5, and 5 is my remainder. So that means my overall answer is, when I divide x plus 2 divided by x minus 3, is 1 plus 5 over x minus 3. Now this looks like it's in this form, and I know what each of the transformations are. Okay, so I'll talk about what the transformations are in a minute. Let's go ahead and take a look at method number 2, pattern matching. So here's how you would pattern match. So method 2, patterns. So my goal when I'm looking for a pattern is I want to find a x minus 3 in the numerator to simplify it too. So I'm going to go ahead and write my denominator first, and I want an x minus 3 in the numerator. And you'll see why that's important in a little bit. But now the question is, for these two to be equivalent expressions, the question I need to ask myself is, what do I need to add to x minus 3 to get back to my original plus 2? So what do you need to add to negative 3 to get to 2? And that is 5. Think with me on this. So negative 3 plus 5 is 2. So these two are equivalent expressions. Okay, so that means I can rewrite this as two fractions. So x minus 3 divided by x minus 3 plus 5 over x minus 3. And the reason why I can do that is the same as why I can rewrite 1 plus 1 over 2 as 1/2 plus 1/2. I'm just splitting up the fractions here. Okay, so once I have that, you will notice that x minus 3 times x minus 3, that is just equal to 1. And I have my remainder 5 over x minus 3. Take a look. 5 over x minus 3. Take a look. This answer here is the same thing as our answer from method 1. So the two methods give you the same solution. It's just two different ways of solving the question. Okay, so now that we've divided, what do each of these variables mean? So going back to our general form, we have 1 That 1 represents a shift up by 1 unit. That 5 means we have a vertical stretch. And our value of C, our 3, is a shift right by 3. Okay, now that we've listed our transformations, I can go ahead and graph it as our final step. So here's my graph. Taking the original graph right here, I'm going to go ahead and shift it to the right by 3 and also shift it up by 1. So the easiest way to do this is just to make note of where the asymptotes are. So I moved it up by 1, and then I want to shift right by 3. So here's my asymptote at 3. And I also have this vertical stretch. That's a little bit harder to see, so go ahead and just draw it in. So here's my graph, and the rest of my graph. And that's enough accuracy to tell me you understand what transformations are. Okay, and that is my first example. And in my next video, I'm going to go over example number 6 and 10.